Hi students, myself Tanmoy Dotto, Assistant Professor, Department of Chemistry, JS College of Engineering. Welcome you all in my second lecture of Polymer. In the first class of Polymer, we discussed about the few parts of the classification of the polymer, like depending on the origin of the polymer, depending on the structure of the polymer, and depending on the thermal response of the polymer. Okay, so this type of, or depending on the homopolymer, copolymer, and depending on the thermal response, like thermoplastic, thermo setting. So these kinds of classification we already discussed about the first class of the polymer. But there also some kind of another types of classification also present in case of polymer. So today we will discuss about the remaining parts of the classification of the polymer. So first of all, today we will discuss about the classification of the polymer depending on the tacticity. So in case of, if you think about the tacticity, then tacticity is the relative stereochemistry of the adjacent chiral centers within the macromolecules. So this is called the tacticity. So tacticity means it is the relative stereochemistry of adjacent chiral centers within a macromolecule. Generally, tacticity applies to addition polymer with one non-hydrogen substitute attached to the carbon chain for each monomer unit. Tacticity has to do with which side of the chain of the R group present, or it is the another side chain. When I will show you the examples, then it will be more clear to all of you. So look here, if you think about the tacticity, there are three kinds of polymer present. First of all, in case of tacticity, look here, it is the isotactic polymer. What is the meaning of isotactic polymer? Isotactic polymer means it is mainly all the groups are present in the same side of the chain. Okay, so this this chiral chain, this C's are all the C, it is not. So this C and these carbons. So these carbons are these carbons are chiral centers, isn't it? These carbons are chiral centers. Like this. Look here, these green color carbons are chiral centers. All the green color, green highlighted carbons are chiral centers. So in case of chiral center, because it is applicable for where chiral center present. Okay, what I told you. Now in case of chiral center, this is the direction of the CH3 is very much important when we'll put the RS nomenclature, RS configuration. I already discussed about the organic chemistry. This is very, very important. Now when all the R groups present in the same side of the chain, then it is called the isotactic polymer. Isotactic polymer. Okay, so if the chains are present in the opposite direction, okay, look here, in case of if the chain present in the opposite polymer opposite side, then it is called the syndiotactic, but it should be alternative manner. This is called the syndiotactic, but this is, look here, this is the alternative manner. Alternative manner means if one methyl group present in the one side of the carbon chain, then another methyl group will be present in the another side of the chiral carbon in the alternative way or alternative manner. So this is called the syndiotactic polymer. And third is the atactic polymer. Atactic polymer means there the direction of the direction of the methyl group, this will be in the random manner. Okay, so there is no particular sequence by which you can consider that in which side the methyl group present with the chiral carbon. It may be here, it may be here, then it may be here, or it may be here. So there is no particular sequence or no particular order by which you can take it as it is maintaining in a particular order. Okay, so this is called actually atactic polymer. So depending on the tacticity, what we discussed, depending on the tacticity, there are three kinds of polymer you have to keep in mind. This is the another kinds of classification of the polymer. So one is the isotactic. Isotactic means all the methyl groups are present in one side of the polymer chain. This is called the isotactic polymer. When the methyl groups or maybe R groups, whatever, not necessarily that it will be always methyl group, all the R groups present in the opposite side in alternative manner. Okay, in alternative manner, then it is called the syndiotactic polymer. And when the methyl groups present in the there is no particular sequence, there no particular way, randomly they attached, the R groups attached with the chiral carbon, then it is called the atactic polymer. So this you have to keep in mind, and the examples also you have to keep in mind, because if you face the question in the exam time, then what you have to do, you have to draw these three pictures. Okay, these three pictures you have to show in the question paper. This type of pictures you have to show in the question papers, and you have to properly explain the three types of polymer. Okay, now we'll move to the another most important types of the classification of the polymer, and this is called on the basis of or mode of the synthesis. This is very important, you have to keep in mind. Okay, so depending on the synthesis, there are, first of all, there are two types of polymer. First one is the addition polymer, another is the copolymer. Okay, so first condensation polymer, okay, not copolymer. So first I will discuss what is the addition polymer. So if you think about the addition polymer, then look here, when molecule of the same monomer or different monomers simply add together to form a polymer, this process is called the addition polymerization. The monomers used here are unsaturated compounds such as alkenes, alkynes and their derivatives. This mode of the polymerization can take place through formation of either radicals or ionic species such as carbanions and carbocations. The monomer usually contain a double bond. So if you see the examples, it will be more clear. So what is the basic principle, or what is the meaning of the addition polymer? What I told you, the meaning of all the things is that in case of addition polymer, the monomer, there will be some kinds of unsaturated part. Okay, look here. So in case of here, it is the ethylene. You know, in the ethylene, what is the meaning of unsaturated part? Unsaturated part means there must be a double bond or a triple bond, whatever. So when these two monomers attach with each other, or when these two monomers connect with each other or add with each other, then what happens? This double bond will break down, and there the formation of the polymer occur. So look there, there is an important part. If you think about the ethylene to polyethylene, the double bond will break down and single bond formed. Okay, so but what is the thing is that there is no production or no generation of the another small molecules. That means ethylene to polyethylene just breaking the bond and making the bond, but there is no generation of the any byproduct in this process. This is called the addition polymer. So you have to keep in mind, in case of addition polymer, there that's why it is very much required that that unsaturated compound should be involved in case of addition polymerization. Why? Because if there are only unsaturated compounds present, monomer present, then only it is possible that by the bond breaking and bond making, their new polymer will be formed. Another example also present, look here, that is the TFE, tetrafluoroethylene. Okay, all the 4 H groups are here replaced by the fluorine, and in presence of catalyst they polymerize to PTFE, Teflon. Okay, this is very common compound, you know, Teflon. I will also discuss in details about the few of the specific polymers and their applications also. But here look, it is the PTFE or the Teflon. It is also such kind of addition polymerization where no such kind of small molecules are produced, only their bond breaking and bond making occur. But if you consider the condensation polymer, then in condensation polymer what happened there, what I told you, that in case of condensation polymer, this type of polymerization occurs through a series of independent reactions. Each such a reaction involves the condensation means bond formation between the two bifunctional monomer. This is very important, two bifunctional monomer means like there will be alcohol group, this is the functional group. So this kind of two bifunctional monomers will react with each other. Then after the reaction involves these molecules, there will be some kinds of small molecules will be produced. What I told you, in case of the addition polymerization, there is no generation of the such kind of small molecules. But when such kind of functional groups will take part in the reaction, then obviously there are some kinds of small molecules like H2, like NH3, like HCl. These kinds of small molecules will be produced. Okay, and when this kind of small molecules will be produced, then this reaction will called the condensation reaction. The very small molecules means very simple molecules. Okay, but these some kinds of byproduct will be produced. These molecules of the moderate size then combine together to form polymer. Since in this process the polymer is the polymer formed in stepwise manner, it is called the step growth polymer. Also keep in mind also that another name of the copolymerization is that this is also called step growth polymer. You can see the question in the form of the in this way, that what is the step growth polymer. Actually step growth polymer is another name of the copolymerization or the copolymer. So this you have to keep in mind, and the process is called the step growth polymerization. Example, there are so many examples are also present. Like if you think about the about these examples of what I told you, that there will be a reaction between the two functional groups. Okay, just if you concentrate here, that in the first compound there is one functional group, this is the functional group. Another compound, another from the another functional group, there will be H. So this H and OH will take birth to formation water. Okay, minus H2O means it is produced with the polymer. When polymer is produced, then this H2O will be also produced, and when this H2O will be produced, then what happen, one bond will be formed. Look here, in between these two compounds, like if you think about that in the product, what happened, look, there is a bond means so this after releasing these two compound, there will be bond formation occur in between these two compound. Okay, so that means we are getting a particular polymer. Okay, so what is the difference between addition and the condensation polymerization? This is very, very important also. The different, you have to differentiate between addition and the condensation polymerization. So if you think about the addition polymerization, what I told you, that the monomer, in case of monomer, must have at least one multiple bond. For example, multiple bonds means it is maybe double bond, triple bond, etc. But in case of condensation polymer, the monomer must have at least two identical or different functional groups, because in case of condensation or step growth polymerization, what happened, the reaction occur in between the two functional groups. It is not related to such kind of double bond breaking or triple bond breaking and formation of the single bond, not like that. So there must be some kinds of functional groups also present in case of the condensation polymer. Second difference, that monomers add on to give a polymer and no other byproduct is formed. This is already discussed with you, that there will be no byproduct will be formed, but in case of condensation or the step polymerization, there must be some kinds of byproduct will be produced. Third, number of monomeric units decreases steadily throughout the reaction. Monomers disappear at the early stage of the reaction. This is the another case. Molecular weight of the polymer is an integral multiple of the molecular weight of the monomer, obviously, because they are only the double bond breaking and the single bond making occur. So obviously the molecular weight will be integral multiple of the monomer, because all the monomer remain in the product in the same form. But in case of condensation polymerization, there are not such kind of things, because there is some kinds of generation of the byproducts. So obviously the byproduct will come from the monomer, so there will be not directly like this kind of fact you can consider that it will be integral multiple of the monomer. Okay, so now next thing is that high molecular weight polymer is formed at once. The high molecular weight polymer is formed at once, but molecular weight of the polymer rises steadily throughout the reaction. Long reaction times give high yield but a little effort on the molecular weight, and longer reaction times are essential to obtain the high molecule. So these all are the differences. There are some examples also, like polyethylene. If you consider here some kinds of examples are bakelite. Okay, also these kind of examples are also here included. So these all are the differences. Homogeneous polymer is obtained, heterogeneous polymer is obtained. So heterogeneous because there are different kinds of monomers are present. Okay, that's why heterogeneous are present. So these all kinds of differences are very much important for your exam purpose. So you have to keep in mind all these things. Okay, very carefully. You should be very careful about these things. Okay, and because this difference is also very much important. This is 3 or 4 marks question. Then you have to write down all the points sincerely. Okay, now come to the next type of classification of the polymer, and that depends on the molecular force or applications. Okay, so depending on this, there are 3 types of polymers. One is the elastomer, second is the plastic, and third is the fiber. So first of all, what is the elastomer? Look here, that in this polymer, the chains are held together by weakest intermolecular forces which permit the polymer to be stretched. These are rubber-like solid with elastic properties. These weak binding forces permit the polymer to be stretched. The examples are Buna S, Buna N, etc. So that means in case of elastomer, so from the name, I think you can understand that what is the elastomer from the name, that elastomers will be, there are some kinds of properties like elasticity. So when it is possible, it is possible only if the polymers, the chains are held together by the weak intermolecular chain. Okay, so weak intermolecular means they are held together by the very weak forces. Then it is possible that they will be elastic like manner. So these are called the elastomer. There are some examples also you have to keep in mind: Buna S, Buna A, neoprene, etc., etc. These are in the category of the elastomers. Then come to the point of what is the plastics. A plastics is shaped into hard and tough utility articles by the application of heat and pressure. It is used as a plastic. The intermolecular force, this is the main important fact actually, because intermolecular force differentiate different kinds of polymers. The intermolecular force between polymeric chain is intermediate in between elastomer and fiber. So you have to keep in mind that here in case of plastic materials or plastics, here intermolecular force is in between the elastomer and the fibers. So they are partially crystalline. They are mostly held by van der Waals force of attraction. You have to keep in mind that in case of plastics, van der Waals force of attraction is applicable here, or dipole interaction, either van der Waals attraction force or dipole interaction. Typical examples of the plastics are, all of you know very well, that starting from polystyrene, PVC, polymethyl, methacrylate. Okay, so these all are the examples of the plastics. Now come to the next types of the classification, or the next examples or next category. This is the fiber. Okay, so if you think about the fiber, so obviously here intermolecular force will be higher with respect to the plastic and the elastomer. So these polymers possess high tensile strength. From where the polymer, in the polymer the high tensile strength present, because here intermolecular force is higher with respect to elastomer and the plastics, and are used in making fibers. This is due to the strong internuclear force like hydrogen bonding. So here, look here, like the previous case, van der Waals force present as intermolecular force, but in case of the fibers, their hydrogen bonding present which operate the polymer. For example, you know, in nylon 6,6, okay, in nylon 6,6, there it is the example, there in this kind of fibers, there obviously some kinds of hydrogen bonding present, by which polymer remain as the close packing. So these three kinds of polymers are very, very important depending on the intermolecular forces or application. Okay, so one is the elastomers, second is the plastics, and the third is the fibers. So you have to keep in mind that depending on this kind of things, we can classify in the three ways: elastomers, plastics, and the fiber. Now come to the next types of the classification, and in this type, you know, depending on the crystal structure. So if you think about the crystal structure, then their first one is the crystalline polymer, then second one is the amorphous polymer, and third is the semi-crystalline. Now if you think about the crystalline polymer, at first the polymer molecules are very large, so it might seem that they could not pack together regularly and form a crystal. Okay, so that means that in case of crystalline polymer, look there, if you look the structure, in case of crystalline polymer, there is a very high strength, but their flexibility will be lower. If you look the picture clearly, then the crystalline phase is that this is the plate like. Okay, so this area actually, this is the crystalline phase. Okay, this is the crystalline phase. So here in case of crystalline phase, there's a very high strength present in case of like crystal. From the crystal it is come to the crystalline polymer. This is the high strength present, and this is a plate like manner. But in case of amorphous polymer, if you think about the amorphous polymer, the polymer chains looks like there is a high flexibility present. Okay, high flexibility present, and it looks like a worm. Okay, this is the amorphous polymer. There the look the structure, this is the amorphous polymer, and it one type of this looks like a worm. Okay, that twist within the mass. Okay, we can twist the around the mass. This is called the amorphous polymer. So amorphous polymer is very important regarding the flexibility. But if you think about the crystalline polymer, this is very important for the strength, high strength. And in a same picture, if you see that in the crystalline part is look like a plate like this are crystalline, and if you think about the amorphous, this worm like part. Okay, these all are the worm like part. This is called the amorphous region. But actually what we need that in a polymer that both kinds of factors should be applicable, or we need both kind of factors. Like it will be crystalline, and it as well as it will be amorphous, isn't it? That means it will be high strength. It should have the high strength and with the high flexibility. So if we need the two parameters, that high strength with the high flexibility, then what happened? There is another category that is called semi-crystalline polymer. Semi-crystalline means in this polymer it will be a high strength with the flexibility, and that's why it is called the percent crystallinity. That means how much it will be flexible, how much it will be the hard, or how much it will be strength, high strength. That depends on the percentage of the crystallinity. Okay, so there are some examples also. When there are some kinds of toys are present, some kinds of materials are present by the polymer, there some materials are very hard, and some materials are hard with flexible, and some materials there are high flexible, depending on the percentage of crystalline character present or amorphous character present. Okay, so there are some examples also, like semi-crystalline polymer, like polyethylene, like polyethylene terephthalate, like PTFE, etc. Okay, these all are the examples of this kind of semi-crystalline polymer. If we model a polymer as having distinct crystalline and amorphous region, then the percentage of the polymer that is crystalline called percentage crystallinity. This is also important. You have to keep in mind what is the percent crystalline. So students, what you have to do, this is the overall classification of the polymer. So what you have to do, you have to make a chart that depending on which factors we can classify the polymer. That means you have to write down in your copy, like starting from starting from the origin. Okay, so just you have to give the point that origin. Okay, you have to note down the point origin. Then what you have to do, you have to write down the three classification. Okay, this is for your own purpose. You have to make a note by yourself that there are how much categories are there for the polymeric polymer classification, and then you have to write down that each and every point under a specific types of classification. Like specific types of classification means just give the point origin. Under origin, just write down three types of classification with the specific definition and the examples. Okay, then second thing will be a structure of the polymer. Okay, so first one is the origin, second one is the structure of the polymer, and structure of the polymer, there are different kinds of like linear, that all we discussed in the previous class. So second is the structure, depending on the structure, linear, branched, and the cross-linked polymer. Okay, this is the second thing. Then third, you have to write down that the classification based on the types of the monomer. Okay, so there is another category like homopolymer and the copolymer. Third type of third classification or third types of classification. And fourth is the depending on the thermal response. Okay, so it is the fourth category depending on the thermal response. Then in the thermal response, you know that there will be thermoplastic polymer and the thermosetting polymer with a thermoset polymer with a specific example. Okay, then come to the fifth category. In the fifth category, depending on the tacticity, this is the fifth category, and under the tacticity there are three kinds of polymers present, like isotactic, syndiotic, and the atactic. Okay, the fifth category. In the sixth category, you know, on the basis of the synthesis or the mode of the synthesis, there you can find out addition polymer, you can find out condensation polymer. Then difference is very much important. So under the fifth category, you have to write down the addition and the condensation polymer. Then in the next category, the sixth category, then classification depending on the molecular forces. Okay, molecular forces, and there you can find out the three categories: elastomer, plastic, and the fibers. Then next category depending on the crystal structure, like here you can find out crystalline, amorphous, and the semi-crystalline polymer. Okay, so there are total 7 types of classifications are there, and you have to make a chart such that at a glance you can understand that what are the overall classification and what are the examples for each and every category, and with the definition also. So that this kind of chart is very important for the polymers, because in your syllabus that maximum part is covered by the classification of the polymer. Okay, there are some specific types of polymers are also included, which we will discuss in the next class. But before that, you should have some sound knowledge about the each and every category of the classification. So that's all for today. We'll discuss with some specific types of the polymer in the next class. Thank you. Thanks for watching. Goodbye.